Hi everyone. Today we are discussing about elementary signals. In previous classes we are discussing some meanings. What is signal? What are the types of signals? And what are the families of signals? And what are the meanings of time shifting, time scaling, amplitude shifting, and amplitude scaling? These are all in previous classes we are discussing. Now we are clearly entering to the subject on depth. Elementary signals. First one is, these are classified different types. First one is exponential signals. Exponential signals. That means the behavior of the character, either increasing or decreasing of the signals, will be depends on exponential signals. A real exponential signal in its most general form is written as x of t equal to b e a power t, b into e power a t, where b and a are the real parameters of function t. B is the amplitude of exponential signal measured at t equal to 0. Measured at t equal to 0. Depending on whether the other parameter a is positive or negative, we may identify two special cases. If the wave behavior will be depends on the a, that's why it is mainly classified two types or two cases. These are the two cases of the exponential signals. Case 1, decaying or decreasing exponential signal for which a less than equal to 0. Decaying exponential for which a less than or equal to 0. A less than or equal to 0. Case 2, growing exponential for which a greater than 0. We are already see the below diagrams clearly, case 1 and case 2. If the condition a less than 0, the wave will be decreased partially. The wave is decreased partially from top to bottom. And the second condition a is greater than 0, at that situation the wave is growing gradually from lower to higher states. So these are the behaving of the signals with the help of the two conditions, a less than or equal to 0 and a greater than or equal to 0. Next one is importance of exponential functions. Importance of exponential functions. Exponential function is the most important function to engineers, physicists, and mathematicians. Exponential signals or exponential functions are commonly used for in engineering, physics, and maths, etc. This is because the exponential function has almost a magic property that its derivative and then integral yield the function itself. For example, the differentiation of d by t e power t is equal to, it is a formula, the differentiation of d by t e power t is equal to integration of e power t dt, so that will be simplified e of t. That means d by dt of e power t is equal to integration of e power t dt equal to et. This is the formula this one will be used, it will be used further problems. Many of phenomenon observed in nature can be described by exponential functions. There are also some rules to solving the problems. Limitation of a tends to 0, e of a t equal to 1. Limitation of a tends to infinity, e of a t equal to infinity. 4 conditions. Limits of a tends to 0, e of a minus t equal to 1. Limitation of a tends to infinity, e power a minus t equal to 0. So these are the different conditions and different formulas. All are used for the particular situations of the problems. Next one is first one is the exponential signals from elementary signals, and the second one is the sinusoidal signals. The continuous time version of a sinusoidal signal in its most general form may be written as a sinusoidal signal. Related formulas: x of t equal to a cos omega t plus pi, x of t equal to cos of omega t plus pi, x of t a sin of omega t plus phi, where a is amplitude, w equal to frequency in radians per second, pi equal to phase angle in radians. That means when we are propagates the signals from source to destination, at the situation the pulses will be transmitted on the circuit. At the situation we are calculating the behavior of the signals by using the formulas of x of t a cos of wt plus pi or x of t equal to a sin wt plus pi. So by using these are all, we can easily find out the behavior of the signals, either positive sign or negative sign. By using these formulas we can find out the behavior of the signal. For example, we are seeing the below waveforms a cos, for example a cos wt plus pi. So we are observing the starting of the signal. The signal will starts from a, that means top to bottom. In the below signal a sin wt plus phi, the signal will be start from bottom to top. So these are the differences between a cos wt plus pi and a sin wt plus pi. So that means the formulas of x of t equal to a sin cos omega t plus pi, so wt plus pi, x of t equal to a sin wt plus pi will be explains the behavior of the signals and also explain the process of the signal behavior. So these are some important notes. Relation between sinusoidal and complex exponential signals, already we know. This one is the exponential signal and second one is the sinusoidal signals, and next one is relation between sinusoidal and exponential signals using Euler's identity. Euler's identity. E of j theta equal to cos theta plus j sin theta. E of j wt equal to cos omega t plus j sin t wt. Here E of j omega t equal to a cos omega t is equal to real term of e power j omega t. A sin omega t equal to imaginary term of e j omega t. So these are the relations between sinusoidal and exponential. And third one is unit step function. Unit step function. The continuous time version of unit step function is defined by u of t equal to 1 where t greater than 0, 0 t less than 0. In the conditions 1 will be displaced on if the condition t greater than 0 and 0 displaced on the condition of t less than 0. That means the wave behavior condition will be depends on upper and lower states by using zeros and ones. Here u of t at t equal to 0 discontinuous, u of 0 equal to half. Next one is importance of unit step signal. Importance of unit step signal. The unit step signal, the unit step function u of t is a particularly simple signal to apply electrically. A battery or DC source is applied at t equal to 0. For example, closing a switch. As a test signal, the unit step function is useful because the output of the signal due to a step input version reveals a great deal about how quickly the system responds to an about charge in the input signal. About charge in input signals. That means the overall process of unit step signal, it will explain the condition of the signals and behavior of the signals and response of the process in various circuits. So this is the important points of elementary signals. Now we are entering deeply on subjects and we are using several problems and several conditions to applying the problems and simplifying the problems at the situation. We are using different conditions. These are the different types of signals and different types of problems and different types of conditions. Thank you. Next class we are discussing deeply on other topics. Thank you.